Consuelo, everybody. Okay, log equations. All right. First of all, there are three things you have to understand before you can even start looking at log equations. First, you have to know how to change from log form to exponential form. Not the other way around, but from log form to exponential. Well, you do have to know the other way around also, but for this, changing log form to exponential form. Second, and this is very important, you can't distribute the operation log. Okay, now, I'll get to what I mean by that in a little bit. And third, just like with fractional equations, you had to check your answer, okay? You're going to have to check your answers. You can do everything correct, but still get an answer that doesn't work. And I'll show you how you know whether it works or not, okay? All right, so first of all, you should be able to change from log form to exponential form. We've gone through that quite a bit. Remember, this is the base, this is the exponent, and it equals the other thing, whatever, the 16 in this case. So we get 4 squared equals 16. Okay, there are just some examples. Okay, now you can't distribute the word log. You can only distribute numbers or variables that represent numbers. So for example, there's no log in part A, but just to show you, can you distribute the division symbol? No, you can't, okay? Now, therefore, can you distribute the word log? No, you can't. The word log by itself, okay? So let me show you something else here. You don't need to write this down, just listen. If I give you this, can I call that the square root of x plus the square root of, the square root of x plus the square root of y? Can I, quote, distribute the radical to each of those? No, you can't. Why? Because of the plus sign. It's basically what I've been telling you all year. You see a plus or a minus and you can't do it, okay? By the same token, you can't distribute the word log and call it log of x plus log of y. Okay, that's very important. Okay. Now, so I don't mislead you, and you don't really have to worry about this so much right now, but the log of 8 is not a mathematical operation. Okay, the log of 8 is a number, therefore you can distribute it. It's kind of like saying this. Log of x plus y. May I distribute the mathematical operation, the radical, to each of them? No, you can't. But let's say you have the square root of 2 times x plus y. Can I distribute the square root of 2? Yes. Okay? I'm not distributing a radical, I'm distributing a square root of 2, which represents some number. It's 1 point something. So what would you get? X times the square root of 2 plus y times the square root of 2. All right? Now, someone would ask me, can I write square root of 2 times x and square root of 2 times y? Yeah, you can, but it's better to write it this way, to put the radical last. But anyway, the point I'm trying to make is this. The square root on this first thing the operation cannot be distributed. But here, I'm not distributing an operation, I'm distributing a number. The square root of 2 is a number. It's 1 point something. You distribute numbers or variables that represent numbers. Okay, having said that, let's take a look at what's the next thing you've got to know. And none of this is new. Well, just other than the fact that you have to, at the end, check the answer. But okay, let's take a look at another one. Can I cancel math operations? No, you can't. So I can't cancel the square roots and call this 7 over 3, right? What you'd have to do, I don't want to get into this, is you'd have to rationalize it by multiplying by square root of 3 over square root of 3. Okay, that's fine. You should know that. I'm not going to get into that. That's not my purpose here. Okay, but can I cancel the numbers? Square root of 21 over the square root of 9. Yes, I can. Now, the operation's still there. Okay? It's not like the radicals go away and you get 7/3. You just cancel the 9. There's a 3 in that. There's a 3 in this. And you get square root of 7 over square root of 3, which you then have to rationalize, as I showed you earlier. So again, you can perform these things to numbers, but you can't do it to mathematical operations. You can't cancel You can't distribute mathematical operations. Okay, by the same token here, all right, sorry. Can you cancel the words log? No. You can't even cancel the 21 and the 9 here for reasons we'll get to later. But it is just what it is. Now, if you had this, the log of 21 ninths, could I cancel the 21 and the 9? Yes, because you're taking the log of some fraction, 21 ninths. But on problem F, part F here, you can't cancel the logs. You can't even cancel the 21 and the 9. It's only if it was this that you could then say that's the log of 7/3. Okay? All right. Next, you must check your answer. An answer cannot cause you to take the log of a negative number. Now be very careful. I'm not saying the answer can't be negative. Okay, that's not what I'm saying. So for example here, if the original problem has log of x plus 5 in it somewhere, and the answer is -7, then plugging a -7 in for x would cause you to take the log of a negative number. You can't do that, so you'd throw it out and you'd say there's no solution. Okay? If the original problem has x plus 5 in it somewhere, and the answer that you've solved for is x equals -3, that's okay, because -3 plus 5 is 2, and you can take the log of 2. So notice, even though x is negative, it doesn't cause you to take the log of a negative number. How about if the original problem has an x minus 7 in it, and the answer after you do all the work is 6? Then you'd have to throw out the 6. Why? Because 6 minus 7 is log of -1, and you can't take the log of a negative number. Again, it's not that the answer can't be negative, okay? It's that it can't cause you to take the log of a negative number if you plugged it back in to check it. Okay, so let's take a look at some examples. Well, actually, a little bit more first. Remember, what makes a log equation? The fact that you're taking the log of the variable. So this first thing here is not a log equation. I'm not talking about those today. I'll talk about those another day. This is a log equation. That's what we're talking about. Okay, now there are two ways the problem can look. It can have all logs or some logs and some non-logs. Okay? In both cases, you're going to need to use the log rules, and you're going to need to simplify with the log rules. So let's take a look at this first example. You have the log of 5 plus the log of x equals the log of 4. Okay, so you simplify with the log rules. And now, I'm not dividing out the word log or doing anything other than, well, if the log of one thing equals the log of this, then wouldn't those two things have to be equal? So by common sense, I'm just saying, okay, 5x equals 4 and solving it. And now we'll go back and check the answer. Does 5/4, when you plug it in for x, cause us to take the log of a negative number? No. Okay, so the answer is 5/4. Okay. All right, next, some logs and some non-logs. So we're going to get all the logs on one side. We've already got that here. Then we simplify all the logs using the log rules. And now we're going to change to exponential form. So remember, what's the base here? The base is not written, so the base is 10. So we have 10 to the 4th power equals 5x. And again, you need to be very good at changing to exponential form. And then basically just solve it, and you get 2,000. And when you plug 2,000 in for x, it doesn't cause us to take the log of a negative number, so you're okay. Okay. All right. I just want to emphasize again, a log is a mathematical operation causing you to do something, to find an exponent when the bases are the same. You can't distribute a mathematical operation, okay? You can distribute a 7, that's a number. You can distribute a k, because that's a variable representing a number. Okay, you can't distribute division, because that's a mathematical operation. Now, some people would say to me here on the last example, 8 minus the quantity x plus y, aren't we distributing a negative? Well, so that's what everyone says, and that's fine to think of it that way. But really what we're distributing is a -1. Okay, so we're not distributing a mathematical operation. We're distributing a number 2. So here you can't distribute the word log because it's a mathematical operation. And later, you don't have to worry about this now, but you can distribute the log of 13 because that represents a number. Okay, but you can't distribute just the word log. Okay, so here just again, you can't distribute the word log. So this is the second type of problem. We get all the logs on one side and all the non-logs on the other side. That's what we're doing right here. Then we'll simplify using the log rules. And now we'll change to exponential form, solve it. Now let's go back and take a look at the original problem. Okay. In the original problem, if I plug in a -4 there, do I get an or there? Does either one give me the log of a negative number? Yes, both of them do, as a matter of fact. If I plug in the 2, does that give me the log of a negative number? No. So the -4 gets thrown out, and you're simply left with x equals 2. If both of them had been thrown out, you'd say there's no answer, but in this case, just one of them gets thrown out. Okay, let's take a look at some examples. Again, you should try these on your own before you watch me do them. Other than that, let's take a look. So turn this off if you haven't done them yourself yet. Okay, so I assume you've tried these on your own. So let's put, this is the case where we have logs and non-logs. So we're going to put all the logs on one side. Okay, let's simplify with the log rules. So this is going to be x over 5. And now we'll change the form. So this is 2 to the 3rd, which is 8, is x over 5. Therefore, x equals 40. And plugging 40 in where you see x does not cause us to take log of a negative number, so we're fine. Okay, here, this is where we have all logs. Sorry, this is where we have, all logs. So we're going to combine all the logs on each side, and this would be x over 4. Okay, now at this point, just using common sense, because there's one log on each side, we just say, okay, wouldn't they have to be equal? So we can say 3 equals x over 4, and therefore x equals 12. And if we plug 12 back in, does it cause us to take the log of a negative number at any point? No. Okay, let's take a look at this one. This is some logs and some non-logs. So I'm going to move the logs all on one side. Okay, then I'm going to simplify with the log rules. So that's going to give us x. I'm going to multiply the x and the x plus 5, x squared plus 5x. Now let's change the form. Okay, now let's set it, this is just a quadratic equation, so we'll set it equal to 0. So I'm going to subtract the 36 from both sides. And now we'll factor it. And what's going to give me that? Probably plus 9 and minus 4. So we get x equals -9 and x equals 4. And if I plug in the -9, it causes me to take the log of a negative number, so I'm going to throw that out. If I plug in 4, it doesn't cause me any problems, so the only answer is x equals 4. Okay, here, I have all logs on one side and then a number on the other side. So the x squared goes in the numerator, the 8 goes in the denominator, the 5 goes in the numerator, and the 10 goes in the denominator, and that equals 0. Okay, now let's simplify this fraction a little bit. Let's call this the natural log of x squared over 16 equals 0. Okay, let's change the form. Remember the base is e, so it's e to the 0 power equals x squared over 16. What's anything to the 0 power? 1. So we have x, let's get rid of fractions, x squared equals 16. Now, a lot of people will do this by taking the square root. I've always recommended you not. I suggest you set it equal to 0. Factor. So we have x equals 4 and x equals -4. Now, let's see if either one of these causes us any grief. Okay, when I plug in x, if I plug in 4 and square it, I get 16. That's not negative. If I plug in -4 and I square the entirety of the -4, that's 16. So neither one gives me any grief, so it's both answers. Okay? All right, let's take a look at another one. Okay, let's get all the logs on. So we have logs and a number. I don't want my iPad to do that, whatever it was. So here's the one number, so let's get all the logs on one side. So 3 minus x goes in, oh, sorry. We'll just leave it 3 minus x plus log of 5 minus log of 2x equals 2. Okay, let's simplify using the log rules. So this is 3 minus x goes in the numerator, 5 goes in the numerator, 2x goes in the denominator, and we have 2 over here. Okay, now let's change the form. This is base 10 since no base is written, so we get 10 squared equals 3 minus x times 5 all over 2x. Now we have a fractional equation. Well, let's simplify this a little bit. So we have 100 equals 15 minus 5x all over 2x. We have a fractional equation, so multiply by 2x, and you get 200x equals 15 minus 5x. Okay, so I'm going to bring the 5x over, so we get 205x equals 15, and x equals 15 over 205. Now, we can obviously take a 5 out of that, so that'll be 3 over 41. Okay, it is sticking in 3 over 41 for x causes any problems. Well, 3 minus 3/41 is not negative, and 2 times 3/41 is not negative. So, no, it doesn't cause us any problems, so that's the answer. Okay? All right. That's the idea. Hopefully that's helpful to you. If you have any questions, just ask. But remember, you can't distribute the word log. What you're going to do is get all the logs on one side and simplify with the log rules. No, that's if you have this case. Get all the logs on one side and simplify with the log rules, then change the form. If you have the case like number 2 here, where you have logs on both sides, and no numbers other than logs. Okay, just get the logs, simplify both sides with log rules, and then by common sense, we're not dividing away the log of base 7, but we're just saying, well, by common sense, doesn't 3 have to equal x over 4? Hopefully that helps you. Have a good day, everybody.